Welcome to the Teja Statistics. Today we are learning in index numbers the Fisher's ideal index number. Okay, let's see the calculation for the BCom second year business statistics paper 2. Calculate Fisher's ideal index number. The commodities are they given A, B, C, D, E, and here the base year is 1982 and the current year 1987. So the values P0, Q0 and P1, Q1 they given. So what is the formula of the Fishers? So that is summation P1 into Q0 divided by summation P0 into Q0 into summation P1 into Q1 divided by P0 into Q0. So here uh, you have to prepare one table according to this. So first of all P1 into Q0 you are doing P1 into Q0. So what is P1? This is the P1 value. P1 into Q0. This 13 into 14. That is 22 into 18. 396. 15 into 15. 225 like that you have to do. Okay. And P0 into Q0 values. 10 into 13. 130. And 15 into 8 into 70. 12 into 15. 12 into 15 you got here, that is 180. And all the table values you have to prepare. So P1 into Q1 also and their totals also. P1 P0 into Q1 also. Yeah, here the last pair and patches formula. So here there is one value is a summation P0 into Q1 here. This is the Q1 value. Okay, so do the total values and take that values from the table. Yeah, first P1 into Q0 is 1084 total and P0 into Q0 is 782. P1 into Q1 is 1329 divided by 960, under root of this total value into 100. So we got a 138 is the final answer. Similarly, we have to prepare the another Fisher's ideal index number. You can do by seeing this calculation. Okay, commodities again they are given A, B, C, D, E and price in 1970 and quantity also. Price in 1975, that is current year values P1, Q1 they given. So here also we are preparing the same table according to that. So P0, Q0, P1, Q1 we are writing P1 into Q0 and the total, P0 into Q0 and their total, P1 into Q1 and their total. So here you have to do all the total values and you have to substitute in the formula. P01 of F in the sense Fishers under root of P1 Q0 summation P0 into Q0. Similarly P1 Q1 P0 Q1 into 100. So what is the total values? That is 782 divided by 586, 1228 divided by 590 under root. So 1.33 into 1.29 under root value, that is 1.3098 into 100, that is 130.98. Yeah, these are all calculations of Fisher's index numbers. Okay, next we have to see another calculations also. The test of consistency we already discussed in the last session. Test of consistency, Fisher's ideal index number they are regularly asking in your examination. Yeah, just see the calculations also. Yeah, one more question regularly they are asking, show that the Fisher ideal index number is a what we can say, it is ideal index number. That means it is going to satisfy all the tests of consistencies, that is, which we already know: unit test, time reversal test, and factor reversal test, and circular test. Okay, next let's see the another calculation from the time series data. So what is a semi averages method? So for that we are taking one example. Calculate semi averages, moving averages for the trend values to the following data. So years 2001 to 2010 they given, and the income levels they given here. So first of all, for the semi averages method you have to divide the whole data into two equal parts. If the total number of observations are even, then you will easily get the then you will easily get the uh, two parts. If it is odd, divide the whole data into by omitting one middle observation, okay, to get equal number of observations. If the total number of observations here are 10, okay, then you can easily get 5 as a part 1, another 5 as part 2. Do the totals and averages for that. So they got a total as for the first part is 1790 divided by the number of observations are 5, that is 158, and again the second part they got 640 divided by 5, that is average of the part 2 we got 128. So here the difference is 30. So the total tender line is moving downwards, we can see in the graph also. Yes, like this. Consider appropriate a scale and also draw the data. So this is the value of 138, this is the 158, this is the value of 138. Hence the trend is moving down. So next the calculation is also given, that is moving averages for the 10 values: 2 pma, 3 pma, 4 pma, 5 pma they calculated. So as you can see. Okay, next the 2 pma means the two observations you have to consider and divided by 2. So 170 plus 130 divided by 2, that is 300 divided by 2, that is 150, like that. 3 pma means you have to consider three values: 170 plus 130 plus 150 divided by 3. So that is how you are getting all these 3 pma and 4 pma and 5 pma calculations. Okay, next the most important question, that is fit a trend line to the following data by the method of least squares, or else we can say the Legendre's principle also. So what is this Legendre's principle and principle of least squares? Here the data is given years and production. So 1986 to 1998 they given. So 86, 88, 90, 92, 94, 96, 98. Also estimate the production in 99. So the trend line equation is given by Legendre's principle, the normal equations: sigma y is equals to n into a plus b into sigma x. Sigma xy is equals to a into sigma x plus b into sigma x square. So according to the question, here to prepare the data. So consider any value from that. Yeah, 1986, 1988, 90, 92, 94, 96, 98. Here the deviation they taken as two values. Of course. So consider that is any one of the value as a t. So the x values here you have to consider year minus 1990. So 1986 minus 1990, that is minus 4, minus 2, 0, 2 and 4 and 6 you have to get, and plus 8. So here the sigma x value is 14, sigma y is what they given, that is production as a dependent variable, that is 25, 27, 32, 36, 44, 55, 69. Sigma y also you have to do. Next x square. So this 4 square, that is 16, 2 square, that is 4, 0 square 0, 2 square 4, 4 square 16, 6 square 36, 8 square 64, like that. And sigma xy also you have to do. So minus 4 into 25, that is minus 100, 2 into minus uh, 27, that is minus 54, like that you have to do, and do the sigma xy also. Here the total number of observations are 7, hence you have to consider according to the total values. So first sigma y is 288 equals to 7 into a plus b into 14. So here the next value sigma xy is 976 equals to 14a plus b into 140. So equation 3 and equation 4. On solving these two equations, you have to get the a value and b value. If you solve the two equations, then you will get the b value as 3.5 and a value as 34.1. The required trend line is given by y equals to 34.1 plus 3.5 x. Y equals to a plus bx equation, no? So here they asked you to find the trend or production in the year 1999. So how you are going to calculate? First of all, you have to prepare the x value, year minus 1990. So 1999 minus 1990, that is x equals to 9. So substitute that x value in the equation, then you will get approximate value of the production 34.1 plus 3.5 into 9. So you got 31.5. So if you add both values, that is the production is 65.6 approximately. Okay, approximately 66 we can say that. So this is how you have to calculate the Legendre's principle for the, and also you have to estimate the given value, for the given value the production also in the year. Okay, thank you. This is very important question for the BCom second year people. Thank you.